I'm going to pull another example from your book, and we're going to basically just use the calculator for this, okay? I'm not going to go through the process. I'm going to use the calculator, interpret, from that and all that stuff. But I still have to interpret what the heck the problem's asking me to do, and I still have to, analyze, what notation is given and write down, the variables, pull them out of the problem. So in a study, so I'm going to underline stuff that is important to me. In a study of the accuracy of fast food drive-through orders, McDonald's has 33 orders that are not accurate among 362 orders. Sounds like a piece of a total to me. Construct the 95% confidence interval for the proportion of orders that are not accurate. So, all right, I pulled out my information that I want. I want a proportion, so I'm looking for a confidence interval for P, population proportion, where P represents the proportion, I'm just going to say proportion of orders, I'm just going to say inaccurate orders, just to kind of make it, okay? Proportion of inaccurate orders from Mickey D's for a population, right? I say population proportion. That's what I want. That's what I want to find. That's what this is asking me to find. So let's do it. Let's pull out the pieces. So let's see. I need an N sample size. Well, it's out of 362. So let's do that. 362. 33 orders were success because success was inaccurate orders. That's what I want to find. So therefore, 33 is my X. What kind of confidence interval do I want? 95% confidence interval. That's my confidence level. I want a 95% confidence interval for population proportion of inaccurate orders for Mickey D's, right? So, boom. All right, let's go to my calculator because I'm just going to use my trick and go straight there. That's all the information I need, actually. Stat. Tests. Scroll down. I'm not running a test. I want an interval down to the int stuff. This is interval int stuff. This is where I'm at. But I want it for a proportion, and I only have one sample. So this is the one prop z int. Enter. It asks for x. What was x? 33. It asks for n. What was n? 362. 362. And it asks for my confidence level, which is actually another 95%. Boom. There's my confidence interval. So now let's write it down and interpret it. So what do I say? 0.06, so let's say 0. It all depends on how I want to round. 0.06, I'll go 15 on the left, and 0.1208 on the right. I'll go 4 digits. It all depends on what you ask, but 0.0615, 0.1208. And actually, you see it gives me p hat too. P hat is 0.0912. If I wanted p hat, I could calculate it by doing x over n, or, this did it for me. Okay, approximately. So here's my 95% confidence interval. So let's interpret it now. Well, let's see. What do I say? We are. I don't know why I gotta probably change settings or something to go where make it white instead of black. But we are 95%. We are. Confident that what? That the true value of the proportion of, where do I get this from? Oh yeah, up here. Orders that are not accurate from Mickey D's. Orders that are not accurate from Mickey D's for the population is between, what is the low end? I'm going to put it into percentage form because proportions can be represented as percentages. 6.15%. Here's my decimal. And 12.8%. 0.08%. Right? We are 95% confident that the true value of the proportion of orders that are not accurate for Mickey D's for a population is between 6.15% and 12.08%. I mean, that's enough for me to say that's probably true. A lot of times it is inaccurate. Remember, for more than 5%, we say it's likely to happen. So it might be likely you go to Mickey D's and they get your order wrong. Which I'm sure you guys probably know does happen. Happens. I don't really go to Mickey D's anymore, but you know. Back in the good old days when I ate stuff like that. You know. Now, what if I ask you for your margin of error? How do you calculate that? Well, you could go ahead and use your formula, or you can say, well, my margin of error can be calculated from this. Is the maximum of my confidence interval minus the minimum, and then divided by 2. I could do it that way also. 0.12, so 0.1208 minus 0.0615, and then divided by 2. I get 0.0297, around that, 0.0297, approximately 0.0297 is my margin of error. You know, if you're ever asked for a point estimate, because in this case, you know, we know the point estimate, p hat is the point estimate here. It is given, well, we could determine because we're given the number of successes and the total sample size. But if you're ever asked for your point estimate, if you're not given it or you can't, you know, you can't find it from your thing and you know your confidence level, your confidence interval, you could take the maximum value and add the minimum value and divide by 2. And you can get your confidence, your point estimate that way also. 0.1208, and then add 0.0615, and then divide by 2. And that gives you your point estimate, 0.0912, same thing. Okay? If you're ever asked for that, and you know, sometimes you're asked for your point estimate for the situation from a confidence interval, so you have to know how to separate them from there, or use the formula, or whatever, preference.